So we are, actually, I don't know why that says page 20. I must have an old version here, but we're actually on page 36. And we're going to actually learn how to graph quadratic functions. So we're going to do this a couple different ways. We're going to write the different parts of the quadratic function if we're given a graph, and on the next page we're going to be given the equation, and we're actually going to create the graph. So this is kind of stepping us through. If you need to go back and look at the vocab on the previous page, you can do that. But the vertex here is a low point. It's right here. It's a low point. And we can write it with the ordered pair. And where are we at? -1, -9. So you can just write it like that. Axis of symmetry. The axis of symmetry is the vertical line that cuts through the vertex, and you can kind of see it's dotted here, and it's going through -1. So remember, a vertical line cuts through the x-axis, so it has an x equals equation. So x equals -1 is the equation for the axis of symmetry. And if you were to fold this parabola on the axis of symmetry, you'd only see one line. It would be laying right on top of itself. Concavity, it opens up. X-intercepts right here and right here, where it cuts through the x-axis. And if I'm seeing this right, it's +2, 0, and -4, 0. The domain, this is what are the possible values of this graph. It goes on forevermore. And eventually, all of the x-axis, positive and negative, will be on this graph. If you think of it going out forever, there is no point that on the x-axis that will not be on this graph. So the domain is all real numbers. However, the range is this lowest point right here. This is this point right here, -1, -9. There will never be a lower point on the y-axis. So we will say that our range is y. The y values are greater than or equal to -9. So let's do this second example real quick. Same sort of thing. The vertex right here, it's over 2, up 1. Axis of symmetry is this dotted line right here that goes through our vertex. Again, it's an x equals line. In this case, now obviously if our parabola was going like this, we'd have a y equals line for the axis of symmetry. So it's not always x equals, but in our examples to date, it's been x equals, and it's x equals +2. Concavity, again, it opens up. X-intercepts. So this is interesting because this parabola does not intersect the x-axis anywhere. So this is one of those cases where there are no x-intercepts. There are none. The domain, again, it's all real numbers because every single number on the x-axis will ultimately intersect this graph somewhere before infinity. And the range, we're going to look at our low point right here, which is the vertex, and that is the lowest point on the y-axis, so we're going to say y is greater than or equal to +1. All right, I think I'll stop this video now and make this just kind of a short one and come back and pick up the next page where we're actually graphing the equations ourselves. Bye.